Nicholas Spacey is going to be taking over on this one because he knows a whole lot more about how this works than I do. So I'm just going to turn the time over to him. I'll be watching the chat for any sort of questions or things like that. And yeah, enjoy the show.
Alrighty. So today's going to be kind of more conversational than a lot of our other ones because programming is a very wide topic, right? There's so many different directions that you can go. So we're going to kind of do more of a generalized kind of just discussion about programming within Ftc and within the robots, kind of go over some of the basics here. But there's a lot of options. So we'll explore some of those options, talk about some best practices. But at the end of the day, this is going to be more conversational, try and see where you guys are at, where you're least comfortable, and try and get you those resources that you need to get going or answer those questions directly. I'll be honest, I am not a programming expert. I actually kind of realized this week that it's been about 6 years since I've dived heavily into this. But we do have plenty of resources that we can get you guys and get you going. But we're going to cover some fundamentals. So today we're going to talk about the 3 main different programming environments that exist for Ftc. We're going to talk about some basic Java programming concepts. And then we'll talk about kind of ways to go about programming your robot drive system and then arms. And then we'll wrap up with talking about sensors. And then depending on how long that kind of takes us, we'll see where we go with the rest of the day. So we have 3 main programming options within Ftc that is recommended. You have blocks, which was developed for FIRST, which is a GUI-based drag and drop programming language. And so essentially, you're able to just create blocks, and then it's a very easy way to get started. Ftc or FIRST does recommend starting with this, even if you are planning on using Android Studio later. They still recommend that you start with blocks just so you understand kind of how the workflow works and everything else like that, and the things that are built into the SDK. And then we have Onbot Java, which is a web-based IDE for Java. And so essentially what that allows you to do is have a web page that's hosted by your robot and just be able to program directly in there. So you don't have to worry about kind of having to maintain your own repository that's not on your robot. And then you have Android Studio, which is the recommendation for any advanced users, and I would say is probably the ultimate goal for you to get to. Because Android Studio is a fully featured IDE. You're going to be, this is your professional program, right? This is what in real world people use. So being able to familiar yourself with a fully featured IDE like Android Studio is going to really help you, especially if your end goal is to pursue programming in any means. Being able to learn how Android Studio works as an IDE is going to be transferable to any others out there, like Visual Studio or Eclipse or anything else like that. Right. So looks like most everyone's already used Android Studio, and most everyone is planning to use Android Studio. So that's good to know. At the end of today, we can hop into Android Studio. Again, I guess let's go ahead and ask a question. Does anybody want to go through the process for setting up Android Studio with the Ftc Sdk? You can either pop in chat or unmute yourself. Yes, okay. Yeah, so at the end of this, we'll go through, I'll start a whole new project. Okay, perfect, yeah. So we'll go through and we'll set up Android Studio as if it was brand new, okay? So let's talk about some basics here with programming, and these are gonna be very generalized Java best practices. Because the language, so there's kind of 2 options for programming within Android Studio. One is Java, and the other one is Kotlin. Now, Kotlin is a newer, simplified programming language, and it is getting a lot of adoption. Android/Google has officially declared that it will be the language that they move forward with. And so Kotlin has some benefits in the terms of it's simpler, it has some more safety features in it than Java. However, Java is going to be where you're going to get the most help. Java is the most established. If you're going online and just looking for help from FTC people, everything's going to be in Java. Everything with the SDK is pre-written in Java. And so if you're needing to do more of, copy paste and kind of make modifications to code, Java is going to be that fundamental program you're going to be programming off of, whereas Kotlin would be something you could pursue as an advanced user and as a newer language. So, and if you guys have any questions, feel free to drop them in chat, unmute yourself, raise a hand, however you guys want to do that. Happy to answer any questions as we go through here. Again, trying to make this a little more conversational. The first few slides here are going to be more tutorial, but so best practices. So we have 5 things we're going to talk about. So the first one here is always use proper names. So the idea behind this is that you want to make your code easily readable. And yes, it takes more time instead of just using variable X or ABC or ADS, right? Make sure that you actually take the time, name your variables, name your arrays, name your ints, right? Make all of your objects a proper name. Make it meaningful, make it readable, make it so that at a glance, you can understand what this is, right? So like, instead of just being like, hey, I'm going to make motor 1 and motor 2. Well, that's not really self-explanatory. Cool, it's motor 1, and cool, it's motor 2, but I don't know what that means, right? Whereas if I make it a proper name and go, okay, this is going to be motor front left, motor, drivetrain, and so I can abbreviate that. Like I can do motor front, FL, and then, DT for drivetrain. But if I'm going to do shorthand like that, I should make sure that that is notated somewhere in the code, like in the boilerplate at the top of the code. Yeah, don't name motors after people. Yeah, you want to make sure that whatever thing you're doing, not only is it self-explanatory so that someone else on the team can make sense of it, but ideally you want to try and name your things so that in 4 years, when you've forgotten everything that you did, you can still look at your code, get yourself up to speed quickly, and make adjustments to it safely, right? And so that takes more time up front, but it's going to save you so much time when it comes to troubleshooting and in the long run, right? So make sure that everything's named properly. Now, on top of that is comments. And if you notice, if you name stuff properly, the amount of commenting you have to do will actually be less, because a comment for like a code section can be, this is drivetrain controller, movement. And then with proper naming, instead of it being motor 1, and then you have to add a comment of motor 1 is left drivetrain, right? You can simply just go left drivetrain motor, or motor left drivetrain, and the comment, like that code, becomes self-explanatory of itself. And then, knowing that, hey, this is the POV controller function, or this is our tank drive controller function above it or below it, right? And adding comments so that it becomes really straightforward. Yes, it takes time, but it is so worth it. Okay. And if there's ever a point where it's like, all right, this one line might be a little complicated because we've done the extra work of simplifying it and, taking, instead of 4 or 5 lines of code, we've consolidated that into a single one-liner. Great, that's awesome for efficiency and everything else. You probably want to add a comment right above that going, hey, blah, right? This is what this one line does. That way, again, when you go to troubleshoot and it fails on that line, you can look at your comment and go, oh, okay, that's what the issue was. Great. With that being said, while we're talking about this, is it is always a good practice to have a commented, detailed script, right, or programming. And then there's a process for when you guys like have, right, we finished our code. This is our production code, right? This is the final version of this. You can then make a copy of that, call it production code or whatever nomenclature you want to use, or final revision, right? And you can go through, you make a copy of that and you remove your commenting, or you downsize your commenting to where it is just the actual code itself with minimal comments. And that is purely for saving space and saving the amount of lines, right? So that's kind of an industry best practice, as far as you have your super verbose commented code. And then once you get to your final version, you know, you're kind of done with your troubleshooting, everything's running good, it's passing your tests, and you make your production. So within FTC, what I would translate that to is I would say, you know, it's Friday night before competition, you're done making any programming changes. It's now just, you know, drivers testing with the robot to get ready for tomorrow, right? So you finalize your code, you remove some of your comments, right? You simplify that down, and then you program that to your robot. And I would recommend, since none of us are really planning on using Onbot, that you only have the code that is production. You know, don't have test code or beta code on your robot on competition day. Might seem like a little thing, but if you only have your proper named production code on your robot, you have less chance of activating the wrong program, right? And there are times, I mean, you might have 4 different variants of an autonomous program for different starting positions on the field, right? So minimizing the amount of code that your driver team has to select on competition day is only going to help you make sure the right code is selected. So I'm sure we have all seen a robot or a team that did bad in an autonomous mode because they selected the wrong code on accident, right? And having been a drive team member who's done that is a very painful 30 seconds. So help yourselves out, have as minimal program on the robot itself so that when it comes to selecting, it's a lot easier. With that, name your Teleop programs, you know, in a manner that is very hard to mix them up with. You know, so spell out the name. Don't make it a shorthanded name. You know, make it very obvious, very clear. Like if you have a left and a right side autonomous, or a red and a blue side autonomous, you know, put capital letters, red dash autonomous, you know, what that autonomous function is, so that it becomes very clear for your driver team. So I'm hoping you guys kind of get the points here that naming things in a manner that makes sense, not just the programmer, but to everyone, especially at a glance, is going to help the programmer and anyone else troubleshooting. Now, this also becomes really helpful when you run into parts, especially on like competition day, and you're having a bug and you need troubleshooting help. Or, you know, as we do this camp, right, you have 3 teams together to help with getting your programming going and whatever else. So if you're properly naming everything as you go through this, it's going to make it even easier to get more assistance from your teammates. Yeah. If a rule of thumb, if an 8-year-old can't tell what your names are, it's probably too complicated. Yeah, I mean, have your mom or your grandma read through it. Does it make sense? You know, they don't necessarily have to understand the syntax or the, you know, necessarily some of the processes that the programming does. But if they look at it and can go, okay, yeah, so we're telling a motor to move forward, and then we're telling a motor to be this power, right? That is going to go a long ways for getting more assistance in the future and for your own sanity when troubleshooting under pressure. So any questions with naming things? I will say, right, Camel Case is a industry standard to use, especially within Java. Does everyone know what Camel Case is? So Camel Case is essentially doing is your first letter. Let me back up. So when you're declaring the name of a variable, right, there can't be any spaces in it. It's a single one line of string, right, and that or one line of text with no spaces. So however long that is great. It just can't have any spaces in it. And so what Camel, my brain just froze. But Camel Case, what Camel Case is the first letter is lowercase, but then anytime a new word starts within that line, it's capitalized. And so it allows you to quickly read through, a bunched up of letters and actually notice that it's different words and read it with ease. So Camel Case is having each sequential word within the single line being capitalized. So like if we were to write left drive, the D would be capitalized because it's, concatenated with no spaces. So left drive or left motor, right, would be lowercase l and a capital M for motor. And so that's what Camel Case is. And we'll review that when we go inside of Android Studio. All right, the other best practice is never leave a catch block empty. Yeah, thank you. Yeah, exactly. Actually, the first word would not be capitalized. So proper Camel Case would be that. Yeah, so that's what Camel Case is. Why it got Camel Case as its name, I have no idea, to be honest. That could be an interesting Google search. All right, so catch blocks are probably something you won't dabble with for the sake of the workshop, but we want to go ahead and talk about this as well, just because, again, generalized Java best practice rules. So what a catch block is essentially if you're going to be running into an issue or an error, you're going to have catches. So if you tell it to run something and there's an error, the catch is going to kind of stop the code there and output what you tell it to. And so what we want to make sure is that when you have a catch block, you don't leave it empty. So as you kind of write out your programs, sometimes there's the habit of, all right, we're going to put a catch here, but we don't actually know what to say in here yet. So at very least, have it print out line blah, or, but we want to have it actually say something. So don't just leave your catch blocks with a comment in it and nothing there. Have it at least say error occurred or something like that. Camel, humps in the middle, not beginning. Hey, thanks, Amber. That's awesome. So, I mean, if you guys are using catch blocks in your code already, that is fantastic. If you feel like you're pretty comfortable with Java and programming, you might want to start exploring how do I best leverage catch blocks, right? Because catch blocks are going to be a tremendous benefit to you as you go through and doing troubleshooting. And again, catch blocks is one of those things that you could probably simplify or even remove when you do that revision change from, to production code. So as you no longer need to troubleshoot everything because it's working properly, you could go through, remove some of those catch blocks and everything else. Now, I want to make sure that I'm being clear here. I'm not saying make a bunch of changes to your code and then show up at the competition without ever running this code. When you do your transition from your programming to your production code, you still need to test that code, right? Because you've made edits to your code. So what I I don't want to happen is you guys show up, you know, Friday night, you finalize, you make your production code, you write it to the robot, and the next time your robot runs with that code is Saturday morning and there's issues, right? You need to make sure that if you're going to do a model where you're going to go to a production code for events, which I would recommend, that you plan ahead and you make sure you have testing for after that deadline. So like, let's say if I were running a team and we were meeting Friday night before competition, or if it was Wednesday before competition and that was our last day where we were going to be making changes to code, right? That you have that deadline and then you have 2-3 hours or even just an hour, but you need to have some amount of time where you're driving, you're testing every function of the robot, testing your autonomous programming, everything, because you made changes, right? And then it's, okay, we found this little bug, fix that in the production code. Found this little bug, fix that in the production code. But if they're major bugs, then you should probably just go back to your last known good working version, see if you're able to reproduce the bug. If not, then leave it the way it is, move forward with that code, right? Because if you're inducing what are called regressions, right, or bugs that you've already fixed, the best thing is to go ahead and revert your code, go back to what was known good, and go from there. Okay. So with that, plan ahead. You know, pen and paper is still great, even for programmers. And that might sound like a weird thing to say, but it is a lot easier to sit down with your team, do a quick sketch, whether it's on pen and paper, whether it's an iPad, whatever it is, do a sketch way before you even open up your programming IDE of choice, right? Even before you put a type a single line of code, sit down, hash out what you want your program to do. And it can be something as simple as control arm list, right? Like simple brainstorming sessions. But then you want to break that down and you want to go, okay, I want to be able to push the A button on my controller and that perform X action. Okay, so what does that need to look like within the code? All right, so I need to receive input. I need to execute a function, which in this case, let's say it's like a linear slide. Okay, I need to press a button. I need to power on a motor. I need to set the motor to go to a certain destination. Once it's at that destination, let's say it's a linear slide with a grabbing arm at the end, right? So, and I want to do all of that with one button press. So the arm extends as far as it can go, and then it closes teeth. So I need to receive input, power on motor, extend arm until X point. Once it's at X point, then I need to close servo, then I need to retract arm, right? So I press the A button and it does those 3 actions. Now I have a clear idea, I've written it out, of what I need to write my code to do. You know, and then that is going to probably get simplified to a single function. But within that function, what does that look like? So sketching out this, doing flows and everything else like that, it's also going to be super helpful if you are planning, you figure out what naming conventions you want to use. What is the name of this function going to be? What is the name of our variables going to be? You know, and do this as a group so that everyone is on the same page, especially if you're in a team where you have multiple coders. You want to make sure everyone is following the same nomenclature and the same programming names, right? So you're using the same variable names, you're using the same function names, that everything is the same across the board, and that you're not duplicating it. Not exactly the same as pseudocode, right? So this is going to be more just doing flows. So it's not even writing out code. You're not worried about syntax. You're not writing out lines of code. You are simply creating, like if you're talking about your variables, you're creating a list of what those variables are, defining what they are. And the idea of I'm going to write a function that is extend arm. Okay, what is the purpose of this function? And then what this can all do is all of this work that you're doing before even opening the IDE can get translated into the boilerplate. And all of a sudden, you've just done all of the commenting for your code. It's already pre-made, and you just have to put it in to the top of your code, right? What pseudocode is pseudocode is typically made for examples, or essentially it's code that could function, but isn't designed to, right? So it's code that already has proper syntax, mostly used as an example. So, or for the purposes of explaining a logic, right? And we can go over some pseudocode later. But like you can argue that like when you open up the SDK, for those that have already done this, right, there is example op modes for you. You can argue that those sample op modes are pseudocode because it'll compile, but it's not going to do anything because it hasn't been fully fleshed out, right? Pseudocode would also follow underneath examples. Like Game Manual 0 has several different pseudocode blocks. And essentially, instead of it being the actual proper format, it's simplified or it's done in a means so that concept is better portrayed than if it was actually being programmed. So pseudocode is non-real code. So what we're talking about is more setting up flowchart and kind of stuff for laying out the foundation or the ideas of what you're trying to accomplish with your code. So like for instance, as an example, if I was a part of the programming team for our color relay, right? I'd want to sit down with the team and I would want to go, okay, so we have these different colors that we need to interpret. So how are we going to do that? Right? We need to have a function that's going to be pulling input from our color sensor. And depending on what colors those are, it's going to do different actions. So I would probably want to program in a function for each color and what that color wants you to do. So that when you come into contact, you then have your next function called, it's going to execute that process. And then you're going to hit, where that ends. And you're going to read and it's going to hit the next one and you're going to go forward with that, right? So having that logic so that when you sit down and you start coding, you're going, all right, I need to create 5 or 6 functions. This is going to be the trigger for that function. And this is what that function needs to do. So you already have your flow or the logic. You already know what you need to do. Any questions on that? By the way, this is massive kudos for getting any of the judged awards, especially as if you're doing these meetings properly, they're being documented. And if you do digital documentation, fantastic. You literally can document this in a way, you copy paste it over for comments, and you're already halfway there for having your code commented properly, right? So it gives you a opportunity to kind of do half of the work. So when you do sit down to code, you can focus on the coding, commenting, and everything else is already there. Commenting your code is also going to go a long way to help you with judged. All right. So within Java, there is arrays and Arraylist. Yes. Yeah. So brings up a great point. And this is something we'll talk more in depth in a little bit. I far too often see that FTC teams go, well, this is the builder and this is the programmer. And the thing is that you somehow silo or isolate yourselves. The issue is that a well-oiled, right, to use to borrow a term, the well-oiled machine is going to be a robot that ties together hardware and software. Meaning if your programmer and your main builder are isolated, you're never going to get that cohesion you need. Because it's like, you could realistically argue that the robots FTC makes is an RC car with a fancy arm that responds with a button press. But it's more than that, right? It's far more complicated than that, because our robots are actually able to do things on their own. But beyond that, they are a better cohesion of that software and the hardware than just a RC car, right? It may look at it as simply just push forward, car goes forward. But there are so many functions that you can do to make your drive team more efficient that have nothing to do with hardware, have everything to do with how you are manipulating your drive team via the software. Okay, and we'll talk about that a little bit later in more depth. But just kind of keep in mind that what your software does can improve what your hardware does. So if you have a hardware issue, and it's like, all right, the hardware issue is going to take us several hours to completely rebuild the robot to fix, or it's something we can overcome in software, that software may be a better fix for a hardware problem. Now, it's not always going to be true, but just keep that in mind. Your software and your hardware need to be cohesive and work together properly. So with that, so let's talk briefly about arrays versus array lists. And the advanced teams are going to probably use this more so. Arrays are not something you need to be super concerned with when you're first starting within the scope of FTC. But if you want to pursue Java further, or as you start to do more advanced functions within Java, and you're wanting to store sets of variables, arrays are going to be kind of handy. And so essentially the main difference between an array and an array list kind of listed here on the page, right? It's easier to remove or add elements from an array list than an array. An array list is only one dimensional. So what does that mean? Well, within Java and within programming, you have multi-dimensional storage sets. So if you think of a chessboard, right? A chessboard is a two-dimensional array. You have A, B, C, D, E, F, G, right, going across one way, and you have 1, 2, 3, 4, 5, 6, 7 going down, giving you a grid system. And so every single socket contains information, right? Whereas an array list would only be able to be A through D, and you would need another array list for 1 through 7. Whereas with an array, you can have a single array object that is defined with those limits or those scope that we're going to be A through G and 1 through 7. And then you can populate data within that array. Now with that, is array list can be variable, meaning you can just add and remove elements from an array list without any issue. So if I have a list of content, I can just drop something off and just add a few more things to it with no issues. Whereas with an array, I have to define what that array is going to be. So it can be a 10-slot array, 12-slot array. And if I have a 12-slot array and I want to add a 13th item, well, now I need to make a new array that is a 13-slot array that includes the 12-slot array and add one more item. Yes, you can make a 2D array list by making an array list of array lists, but why? Right? Like if you are already doing your planning session.
Because arrays are a pain. And 100 times rather work with lists than true arrays.
Right, yeah, so right, it comes a means of each. But if you're doing your proper planning, and you're planning out, okay, what is it that we're looking at for what we need this array to do, right? So it's like, all right, we've hit a point where we want to use an array. Great, let's step back from the IDE. Let's do a planning session. What is the purpose of this array? What are we wanting it to achieve? Is an array list going to be the best thing for us? Or do we need that multi-dimensional element? Is this going to be a highly dynamic changing 2D system? Okay, so it's a highly dynamic 2D system. An array list is probably going to be the best way to do it because, again, you can edit and drop things on the array list really easily. So there's always going to be give and takes. And there isn't really a great answer saying, well, arrays are better or array list is better, right? They both can accomplish the same thing given enough time. And so it becomes, we start to dive into a means of what is efficient code-wise? What's going to be the less lines of code? Because as you introduce more lines of code, it's going to make it harder for troubleshooting and more likelihood of something being, fat-fingered, programmed improperly, or harder to troubleshoot. So it's like, all right, so if we can accomplish the same thing with an array list and an array, you start looking at, okay, which one's going to take less? Which one has less overhead on the compiler? Which one has less overhead on processor time? And those are really kind of advanced topics. So, if you want to dive into the weeds there and do that, fantastic. That's awesome. But for the sake of our scope, we'll kind of back a little bit from there. But essentially, just the point I want to try and get across is arrays you want to make sure are predefined. They technically have more usability by being multidimensional, versus an array list is probably within FTC what you're going to use the most, as it's a single line, right? So if you guys are getting to the point where you are doing 2D or 3D storage matrix, awesome. That is honestly amazing. I myself still have a hard time wrapping my brain around a 3D storage matrix. But if you guys are going to 2D and it needs to be a highly dynamic, like Kieran, hopefully I'm pronouncing that right, Kieran pointed out, you can make a 2D array list by making an array list of array lists. And that might be the way to go for you, especially if you're far more comfortable with array lists, right? Get to where you're comfortable first. Once you have a comfortable understanding, that's then where it's like, all right, let's branch off, let's learn some new things. So now we're going to talk a little bit about keeping your project organized and version control. So I should have done a survey here. Who has used Git before? Okay, so a couple of us. Who doesn't know what Git is? All right, so you may or may not have heard of GitHub if you're into programming, right? Which GitHub is not the same thing as Git, just to clarify there. GitHub is a online community at this point that is designed and built on top of Git, but Git itself is actually different than GitHub. That's, I think, a confusion that happens very typically at the beginning. But so let's talk about Git for a second. So Git was designed by Linus Torvalds, yes, the guy who made Linux, as a version control that is able to be easily shared. So what Git does on a functional level is it allows you to keep iterational versions. So what that means is, let's say I have my version A of a code, and then I want to go ahead and I make edits. I now have version B. I make more edits. I now have version C. I make more edits. I now have version Z. And what Git does is it allows to maintain all of those different versions and even be able to do compares against those versions and be able to restore back to one of those versions if I need to. Right. So a little bit before we talked about how having that production version, right, that would be one iteration of that code. And then we're having issues in this production code. Let's go back to where before we edited it. You can leverage Git to do that reversal of that code. Okay. So on top of leveraging Git, though, for version control, you also want to make sure that you are keeping the structure of your project clean and organized. What does that mean? That means that you have proper created folders or OUs, organizational units, right? So like within Android Studio, a lot of times those are called packages. But essentially what the goal is you want to be able to make it so that it is organized in a manner that is logical, makes sense, and you know where stuff is. So if you're making autonomous code, you probably want to have that be in a folder called autonomous code. And if you're going to have multiple different variations, you may even want to have a subfolder within that that is, this is autonomous code red alliance or blue alliance, right? If you have those kind of variations. And then when you go to your drivers, you might have driver. And then depending on if you're going to have different variations there, you might want a tank drive driver or a POV driver or, whatever you guys end up coming up with. And you might even want a folder that's, Macadam drive or West State or, whatever those are, because you're going to have multiple codes. And so the thing is you don't want to have a state where it's like you have a folder that has 100 different codes in it, right? Like code files. Because all of a sudden it's like, all right, I got to find that code. All right, well, it's in here. Okay. But where? And there's always nice things of being able to do searching and everything else like that. But where having your folder structure built out properly like that comes really into play is when you're going to do backups, right? So Git's going to control your versioning for you. If you leverage Git, which I highly recommend doing. Learning Git is kind of out of scope for what we want to cover today. So if you're not familiar with Git, there are some fantastic resources for learning Git. We can get you to that. We can talk about some of the basics within Android Studio for you once we get there. But that's kind of, we'll dabble a little bit in it, but properly learning Git, I would have to say, is something you'll want to do. There's lots of great resources out there for that. But I want to talk a little bit as an IT guy, I want to talk a little bit about a difference between backups and a cloud sync. Okay, so a lot of people will think, okay, well, a cloud sync is a backup. And it's a protection. The reason why I say it's not a backup, but it's a protection, is that cloud syncing protects you from your local data being corrupted or destroyed via a hardware malfunction, or the device is lost, or something else like that, right? It protects your local repository. If it's lost, you can get it again. But because it is a syncing function, if you are hit with any kind of issue where, hey, something's deleted or something is encrypted or anything else like that, that's going to sync to your cloud service. Now, most cloud services like Google Drive, OneDrive, they offer versionings, right? So you can kind of do version restores or version backups, right? But you want to still make sure that you have a safe and protected backup, meaning you have taken your folder structure or your Git repository, whatever you are doing, and you make a physical backup of that, meaning you have taken that into another drive that's offline. Maybe you do that once a week, maybe you do that once a month. But essentially, you want to be able to take your backup and be able to go, this is a snapshot in time. This is what this looked like at X time when it was copied over, and it will forever look like that until a new backup's made or whatever else. So buying a couple of flash drives would be fantastic, right? I mean, you can buy these are 32 gig flash drives that you can buy Amazon, $25 for 3 of them. It's a small investment, and having 3 versions of it will protect you against a single loss via theft or anything else like that. And you can give it to different team members so that if you lose internet, you lose whatever else, you still have access to your backup. But yeah, so I just wanted to kind of touch on that a little bit, some of the differences, cloud backup versus cloud sync. So leverage Git to get your version history, your version control. Make sure you guys have things properly organized. Use logical names for your organization, right? Don't do folder 1, 2, 3 or folder 12 or, you know, layer 2. Like, make what is in there make sense, logical at a glance. And then have backups. I actually still have a backup from when I was doing robots 7 years ago. So, you know, they're good to have and just around. And sometimes it's fun to go back and look at that code. All right, so let's talk about programming your robot more specifically now. So we're gonna kind of separate this in a little bit into drivetrain and then your arms. Okay, and so one of the things that I still need to learn better, so I apologize if the knowledge will be lacking, but is properly leveraging the SDK from First. Right, so First has kind of gone together, created this great library for you that already has all of these built-in functions for being able to call your motors and be able to talk to Control Hub or to the phone, and being able to set your speeds of your motors, your servos, be able to read sensor input, write all of these things. And so when you're getting going and off the start, leverage their things, and we'll go through that process at the end of the slide deck. We'll open up Android Studio and we'll go through that, editing some of that and everything else. But some of the flow for that you're going to want to kind of do here is like when you're doing your drivetrain. Again, this is going back to that cohesion between software and hardware. So you have, let's just say, for simplification, you have one drive motor on each side. Well, those drive motors are going to be in a mirrored operation, right? So one side needs to go forward, one side needs to go in reverse, so that they both go the same direction. And so you can set what direction your motors are. So if you set one motor to forward, one motor to reverse, and you pass a positive integer right for the power, they're both going to go the same direction, because if a motor is reversed, it's actually going to make that into a negative number so that they both go in the same direction. Does that make sense? So now where that can come into play with, like, say you're programming an arm, like your linear lift, and it's on a rope, right? So you can set what speed you want your lift at with your rope, and then you can use, you know, buttons to set your distances. Well, you can translate that into, I want to keep a value that's always positive, but I want to be able to change direction. Well, you could literally program so that you have a variable that points to the same arm controller, but one be lift motor up and lift motor down. And you could say, I want my value to be, you know, 0.75 or 0.78. And you can call lift motor up or lift motor down, and those can be defined as motor forward and motor reverse. Now, it's probably a lot easier and far better to be able to just do 0.75 and negative 0.75 and keep the same motor. So that's going to come down to what works best for you guys, what you're wanting to do for programming. I would highly recommend using doubles for your numbers within Java, especially for wanting to have precision over a float or just a regular integer. Using a double is going to allow you to have larger numbers and more precise numbers. And then you're going to want to choose either POV or tank drive. The differences between that is essentially with tank drive, right? Each joystick is going to control one side. So forward and backwards for one side and forward and backwards for the other side. Whereas POV is one joystick does forward and back, and the other joystick does left and right. You can even simplify that further, and you can go with POV as a base or as a template, convert that from being two different joysticks to actually a single joystick, So you can use a single joystick to drive your vehicle around. And that might make sense for like mechanism setup, where you have one joystick that does your movement, and then you have another joystick that does your rotation. Again, all up to your preference and how you guys are wanting to do it. Now you'll notice kind of set up on the slide here is we have our drivetrain kind of set up in the flow of your program. So you're going to set up you're going to define your motors, what directions you're going to go. You're going to define your motor power with a double and how you're getting that motor power. You're going to choose what kind of drive system you're going to do, what that looks like, how that is modified. You're then going to do a telemetry update because you're going to want to know what your robot is doing, how long it's been doing it, where it's going, so that as you program autonomous functions or autonomous, just like even just outside of your 30-second autonomous, but in Teleop, there is autonomous functions that you can do to help enhance your driver team. And so having telemetry even within your Teleop code will help you there with doing that. And then there's a team out there called Acme Robotics that has developed a Roadrunner suite for being able to make your programming of your robot with very great precision. So I'd recommend go check that out, learnroadrunner.com. But it is a little advanced, but it has some really great guides for being able to get you from point A to point C and kind of understand the concepts that are behind it, as well as being able to implement it in your code. And what Roadrunner does is essentially they've gone and done a lot of the legwork for you so that you can import this module or this, this function into your code and leverage it so that you can have very precise and very accurate drivetrain function for both autonomous and Teleop. It's really cool. Again, it's not going to be within scope of today's conversation, but I highly recommend you go check it out when you have some time. Yeah. Yes. Yeah. Roadrunner has built-in telemetry, mechanism drive. It's like if you're building a drive system and you want it to be good, go learn the Roadrunner. So highly recommend it. Yeah. So that's kind of, hopefully this will make more sense when we kind of hop into the IDE as well, but that's kind of where we'll stick with drivetrain for today. So let's talk about arms for a little bit. So when you're programming an arm, you're going to want to determine if it's a servo or a DC motor, right? How are we going to do this? And again, look back at your planning sessions, because your planning session doesn't need to just be software. It needs to be hardware and software. So as you plan out, okay, this is what we want to do, right? So our goal of our robot is do X operation. What is the best hardware to get us to do that? What does our software need to do that? Right? So, you should already have it planned out. All right, so our arms, we're going to be using a DC motor for this, or we're going to be using a servo. And the hard part here is that you are limited on what resources you have, right? You only have 8 motors, but you have 12 servos. So where, technically with that number, your motors are going to be your more valuable resource, more limited. So be sparing with where we're going to do motors. And it's like, all right, well, we're dedicating 4 motors just to our drivetrain. Great. I now only have 4 motors to use for arms or other mechanisms. So is this something that I can achieve with a servo, or is this something I need the power of a motor with? Have those planning conversations and everything else. Right. So when you're coming to do arms and you're thinking about programming it, I would recommend making an arms movement as simple for your drivetrain as possible, meaning make it a single button make it a iterational step, so like you have your D-pad, you want to take an arm up, have it be, all right, I press, right trigger, or I hit the A button, whatever it might be, and it goes to X height. And if I need a little bit of adjustment, hit the D-pad up one and it'll go up, X amount of space, or down X amount of space. Or I can hit left on the D-pad and it'll reset it down, or I can hit right and it'll go up to its top, right? Being able to make these control functions so that it's easily done by the drive team. And you can do augmentations with that. Let's say you have your D-pad, you can have your drive team hold like R1 or R2, hold that button down, and now your D-pad acts as a different function. So instead of it just simply be, iterational gap up, you can set it to where I need that more finite control. So I hold R1 and I press up on the D-pad, and that arm, raises at a steady rate instead. You have options here, but the point I want to try and get across is make it as easy to use for your drive stream. Have it be that power, that button action. Now with that, set power limits, especially if you're doing like an arm with a DC motor. Your motor probably doesn't need to hit 100%. So set your motor that it can only go up to 80% or 75%. Or, have range limits. So if it has an encoder, only allow it to spin so far. Or with a servo, only able to go so far. Now, if you don't have encoders, or servo doesn't have that process of knowing how far it's gone, or if it is something that has potential slippage, friction, or resistance variance, right? So it's not going to always go the same distance. Get some touch sensors, use the magnetic sensor, right? This is where you can start leveraging your sensors, even with inside of your robot, to be able to tell where an arm is. So instead of, like with sensors, there's kind of two ways of thinking about it, right? You have external and you have internal sensors on a machine or on your robot. And so your external sensors are going to help your robot know where something is in the outside world. And then internal sensor is going to help your robot know where something is on the internal to it, right? So like if you have an arm with a linear slide, have it so that your robot knows what stage it's at, so that if somebody gives a command for your robot to do something that would be harmful to it, but let's say you're using a linear lift that has, like a gear, and so it can only go so far, and if it goes any further, you're now going to have a gear chipping against something. Okay, we'll set a limit switch so it can't go past that, or have it be encoded so it can't go a certain distance before that hardware limiter. So as long as you set a software limitation before a hardware one, you're going to make your parts last longer, and you're not going to break something on competition day. And that becomes a huge benefit for when you do autonomous programming, because now your autonomous robot, your robot needs to know where its own objects are so that it can't break itself. So if you have a linear lift and it's autonomous in its function, and you have software limits, it's going to hit that software limit every single time consistently. And so you can use those software limits for programming your autonomous. And if you tie that to a sensor as opposed to an encoder, like you can use a color sensor to detect distance, because you could put tape on an arm and put you could do different colored tape on your arm and have a color sensor. And as your arm goes out, your color sensor is going to know where that is, right? And so that could be a great way for you to control autonomously how far your arm goes or doesn't go. And yeah, Rev magnetic switches are great. They have touch sensors. Honestly, the Rev sensor kit, I think it was like $130, comes with a great slew of sensors to explore with, and then you can get individuals to grow that out. Now, I'm a little bit jealous because 7 years ago, when I was doing robots, we were stuck with Lego NXT, and we literally had 4 ports for sensors and about 3 sensors you could actually use. Nowadays, you have so many more options, and you have sensor multiplexers, which we're not going to really talk about how to use because each one's going to be a little bit different. But you can use multiplexers to get even more sensors connected to your robot. Spend the time to invest in learning your system. And that's one of those things is every sensor is going to be a little bit different. So learn how your sensor works. Do some A/B testing with sensors, figure out what's going to be the best case. Because you might have, 4 rev color sensors, and every color sensor should work the same way, but there's tolerances. And so, do some testing with your color sensors, see which one is going to give you the better value for what you're trying to do, right? And every sensor, going back to programming it, make sure that every sensor is proper named, that it's clear, not color sensor 1 and color sensor 2. Because now you have to have a reference sheet that explains what is color sensor 1, what is color sensor 2. Do ARM color sensor. Or if it's, we have color sensors on the left side and the right side of the bot. Left robot chassis color sensor, right chassis robot color sensor. Or if you have color sensors that are on the arm designed to do different things. This is, distance measuring color sensor. This is our object detecting color sensor, right? Have those match different things. Have it be clear so that as those go and read different values and come back, right, you can easily modify and work with that. And putting labels on them, a little bit of white gaffer's tape and some Sharpie can go a long way for keeping your sensors straightforward as far as when you label them, after your A/B testing, and keeping them straight on the robot. One of the things that happens quite a lot at competitions is, and you'll when it happens because you hear it, because the grinding of gears announces itself with great gusto, right? I'm sure we have all heard the sound of gears grinding. So assume everything can kill itself and put software limitations to make it so it can't kill itself. Now, the other thing that I want to talk about really quick, and this is kind of an advanced topic, is your control loops. Okay, so essentially, right, everything within your op modes or your teleop is all going to be in a single loop. And so every single thing that you do that's a hardware call is going to take 3 milliseconds to process. So every time you say, hey, set power to motor, every time you read a sensor, every time you do something like that, right, it's going to take 3 milliseconds. And so let's say you want to update your hardware speed. Like you have 4 drive motors and you want to update that. And you also have a sensor that is going to bring back telemetry. That turns into 5 different calls, right? And so you have your 4 motors and 5, all of a sudden that's 20 something milliseconds that is transpiring to do that action. Now that's a simplified example, right? The thing is as you get more and more complex, all of a sudden you might have 250 millisecond or a quarter of a second logic times going through this loop. And so as you start to get these larger, more complex things, that's when you start wanting to go the advanced route and start simplifying your code. How can we, wrap this together into a single thing? How can we make these smaller? How can we make stuff that will exit out if we tell it to, so that you don't have these control loops that are taking a quarter of a second or half a second? Because it doesn't sound very long, but in the heat of the moment, your drive stream goes to change something at the last second or whatever else, and there's a half a second lag or a quarter of a second lag. I think most of us probably have played a computer game, right, where it's multiplayer or even like Minecraft. If you have 250 millisecond lag, it's noticeable, right? Like, oof, that's a hard ping. So keep that in mind when you're designing your robot with your control loops. You want to try and keep those sub 100 milliseconds or even less. That'll translate to real world performance in the terms of how quickly your robot will respond to things. yeah, rookie teams will kill parts because they don't set those limitations. So as long as you go into your design process, whether it's hardware, software, anything in between, you just go into it going, this could kill itself. Design limitations so it can't. You are going to make your parts last so much longer, both on a hardware scale, and you're going to save so much heartache on an emotional scale that your parts don't break. All right, so now we're going to kind of step back here and we're going to drop into a question open forum format here. Okay, so I've been talking for a little while here. So now I want to take from your guys' experience and also what we've been talking about, and what are some ways that we can automate Teleop. So we have Teleop, so our drive system is going to be controlled by our driver team. What are some functions, what are some programs we can add to this so that we can augment our drive team with automation? What are some ideas that you guys have? Yeah, turning, we have one in chat, turning 90 degrees left and right with a button press. So 90-degree turns with button press. Found a line to shoot in the same position, so find location on field. Shooting 3 rings with 1 button, okay? So perform X amount of actions. Return to prior position, known position. Face a certain direction. These are all fantastic. What are some other ones that come up with? When a bot stops, have it sense colors. Ooh, that is good, Todd. That is really good. Bot stops, detect, sensor. All right, so in line with that, Todd, let's build off of that a little bit. So how would we build a function for that to work, right? So essentially we're looking at if the bot has no movement, then the color, right? So read from our sensor. Now, what are we going to do with that information, right? So we've said, hey, there's no movement on the robot. What does the sensor say? What do we want to do with that information? What could we do? And like even outside of the content of our camp, right? But what is something you can do with this information? Robot has stopped. We've got sensor data. What can we do with this sensor data? One of the things you can do, right? So you have a drive team. So you have your 2 drivers and a coach, or however your team has that configured. No driver and a coach. But you have a coach that has a phone in his hand, and there is a way to send information back to that phone. So if you have a robot stop and it sees a color, you can have that be sent back to the driver team. So you could use that for some form of, understanding of where the robot is, because there's typically always lines. You could leverage that, like let's say this last year's competition, right? You had to be able to put a wobble goal within certain locations. So if a robot stops, you could read a color sensor to make sure you are in a known spot. Now that does have some limitations because it's only telling you if you are over a piece of tape that's a certain color. But if you're driving, you already know within context where your robot is. Have it in the phase, yeah. But if you, as a drive team, like during Teleop, this could be really great because, like was brought up earlier, having a known spot of, are you on that tape? And so you can have robots stop and have it record on the phone. And the coach can go, yes, you're in the location, or no, you're not on location, right? So there is ways to get information back to your drive team from your sensors as well. That might be something to help with strategies or whatever else. So now, is that during the init phase of autonomous, so before autonomous starts, for being able to detect where the rings are, so your robot can then go towards those rings? Is that what the thinking is there? All right, this is a pretty good list we have here for our automate teleop. Do we have any other things we want to add? Okay, so one thing I want to make sure, we've kind of been using Game Manual 0 quite a bit, but there's lots of great resources directly linked from Game Manual 0 for different things like that. Now, we didn't talk about computer vision. We didn't talk about photometry. Game Manual 0 has got great examples here and resources to take you to all of the different options out there. One of the reasons why I didn't want to kind of talk about it today is there's lots of different paths that you can go down, and then those are all going to have their own quirks and benefits and everything else, right? So I will let people who are far more knowledgeable about computer vision help you in that guide. Again, we're always here to help you guys through the Discord or other as well. But Game Manual 0 has got some great software things to kind of cover. This also has a great guide for setting up Android Studio. I'm going to point this out because we're going to assume you already have Android Studio installed and that you've already downloaded the SDK from the GitHub. Yeah, we had some requests for setting up Android Studio. So we'll go ahead and do that now. So here's my Android Studio, and you can see we'll start a new project here, but here's one of the sample basic op linear modes and flow of that. But let's go ahead and we'll start with a new project here. Or rather, I want to close project. Okay. So when you first open up Android Studio, after you download it and installed it, you're going to get a window that kind of looks like this. And what you're going to want to do is you're going to want to go to the GitHub and download the SDK. In my particular case, I just did a git clone, so I have it on my system. So once you have Android and you have the SDK downloaded, again, detailed instructions, Game Manual 0, you're going to come here to import project. You're going to locate where did you download that project to. In my particular case, I just downloaded in my home directory. And so I have my Ftc robot controller. We'll go ahead and hit OK. And that's going to import that. Now let me go ahead and get a new one. All right, so we'll come over here to the SDK. We'll run through that process. All right, so here's our SDK on GitHub. This is where you would get the Ftc Sdk. And you want to make sure you get the one that's up to date. Everything else. So I'll go ahead and do a new git clone. Git clone. All right, and so what that's going to do is it's going to go ahead and download that from GitHub for us. And inside our folder, we now have FTC robot controller. All right, so I'm going to just do folder here real quick. So, all right, now if we come back over to our Android Studio. All right, so right now we're going to go ahead and you've downloaded Android Studio, you've downloaded the SDK, and this is where we are. All right, so the first thing you're going to want to do is you're going to go ahead and import a project. You're going to want to go navigate to where that project is located. So in my particular case, I downloaded it under FTC. Then we have our robot controller. Go ahead and hit OK. And now you'll notice down here on the bottom right, as you can see, Gradle is building. All right, so when you first import that project, Gradle has to go through, sync everything, build up all the projects, and index everything for you. It takes a couple of minutes here. So we'll just let it go through its process here. So while it does that, does anyone have any questions or anything that they would like to cover in particular while we're here?
I'm going to go ahead and unmute and mention something while this is running here, because me and my team have run into this a few times, is when you're first doing either, which by the way, another way you can do this rather than doing the FTC SDK, if you're going to use Roadrunner, it's actually easier to download the Roadrunner SDK, which has the FTC SDK built into it. Now, there are ways where you can implement, where you can add Roadrunner to the FTC SDK. So if you've already done that, don't worry, there are ways you can do that. But if you're just starting out and you're thinking about using Roadrunner, it's considerably easier, in my opinion, just to download the Roadrunner SDK than it is to take the FTC SDK and modify it for Roadrunner. The other thing I want to note real quick is sometimes the SDK has a outdated version of the Java SDK and it'll give you errors when it builds it, and you have to go and change the version part of it. I don't know if you're planning on showing that, but that's something that I've had to do almost every time that I've downloaded this. So just a couple things.
Your Java from 7 to 8, or?
It's usually the Android version is usually the part that usually it's like.
If
like
you
from
use
29.
Roadrunner, you need to use Java 8.
Yeah.
Instead of 7. And there is the minimum version of Android has to be updated too.
Right. There's also like the actual like SDK, it's like the 28 or 29. I'm trying to remember what the exact number is. You have to make sure that your computer, it always downloads like the very latest version of Android, and you have to make sure that if it's not built on the latest version of Android, that it can accommodate older ones. So.
Gotcha. Yeah. So, one thing I want to point out here. So if you come up here to the project view, this is going to look at it in the actual file and folder view, right? So like we have our team code here. So this is one of those things where it's like, all right, having things labeled and named out in an appropriate manner are really important. And I would argue that some of these naming is not very straightforward, that straight out of the SDK, right? But yeah, so this is what that looks like. So I found that it was easier to use the Android view. A lot of people recommend using the project view because it's a lot more straightforward for being able to create your directories and everything else. Right, so here's going to be your examples. So when you first open up your SDK, you have your FTC robot controller, and then under source, main, Java, the robot controller, and have external samples. These are all sample codes that they have written for you that you can use. So like here's sensor color. We can open this up. You can see it is lovely commented for us and everything else like that. It gives you instructions and then all of these different variables that you need to do, being able to do color sensors. And these are all great for doing those spaces, right? Getting kind of a jump start on going. And they have some concepts here. So where you're going to most likely start is you're going to basically start with your basic op mode linear. So here's our basic op mode. This is where it's like really nice with a fully featured IDE like Android Studio. You noticed it created these little abbreviated sections here. So it makes it easier for making stuff human readable when you don't need to know. So like, oh, this is just our license. Cool, good. But like stuff like this import, you might want to actually be able to take a look at this. So make sure you expand it. Take a look at what what is importing. That helps you kind of understand what other resources are we going off of. What are we leveraging inside of this? And then here's our explanation of this code. So this is a minimal example here for a Teleop op. So as we kind of went over before, kind of like the flow here, right, is we're declaring what this is. This at disabled variable here is to show that it's not usable. So they mentioned that up here in the comments. Right. Remove or comment out at disabled line to add stop mode to driver station op mode list. So if that disabled, it's not going to show up. So we're going to say, hey, we have a public class and we have some privates for within this public class. And then here's our public void run op mode. And here we're defining what those are. So here's our left drive motor, right? And so saying left drive, right drive, like, yeah, that is somewhat self-explanatory, but we should probably go ahead and just say this is right drive motor, right? Now the thing is, you'll notice, hey, this is no longer a defined variable. We defined it right up here, right? Right. So we declared our op modes. So now we need to make sure, hey, this is still a thing. We're going to make this the right drive motor. We're going to make this the right drive motor. Let me put that here, motor. And what's really nice with a fully featured IDE like this is, yeah, I clicked on this variable. It's going to show me where else that variable is used. And you'll notice that the variables that I've changed are now marked as red. And it'll say, hey, I want to create a field or a parameter, or I can rename this reference. Oh, hey, left drive motor. It pulls it right up for you. Great. So there's a lot of help for you as you kind of go through things to help you out with your changes when you leverage a full AE like Android Studio. Yes. Yeah. Your configuration needs to match across all the things. All the things and all the stuff. So here we're defining what our motor is, right? So we declared, hey, we're going to have a DC motor, and this is its name. And then we're defining that that motor is equal to the hardware map of a DC motor class with the name left drive. Okay. And so this is where we would set that direction, right? So our left drive is going to go forward. The mirror of that is going to be the right drive motor. So that needs to go in reverse so they both go that same direction. Yes, you can rename everything at once. So if we do a left drive motor, let's say, it's been a little bit since I've done that. Find usage.
Yeah, if you right click refactor and then rename, you can refactor,
Refactor rename. Thank you.
rename.
Yeah, so we can make this. Ta-da. Thank you. And then here's our while loop for what we're going to do during our actual op mode is activated, right? And so this is that control loop that I was talking about, where it matters what you're doing within that control loop so that it is very time sensitive. You know, so we have defined our doubles here for our power, so left power, right power. And we just have defined our doubles for our POV view. So you can see we have POV view and we have tank mode by default in here. So it's like, all right, we're going to do POV view. We don't need tank mode. Get rid of the tank mode code, simplify that. Awesome, right? So we're going to be using left and right power, and we're going to be doing POV view. So we need our drive and our turn, and we're setting this to equal gamepad left stick and right stick. And then left power is going to equal a range clip number of our drive plus turn, right? So that when we then send that power, we're actually going to send set power as left power or right power. And then we're pulling our telemetry. So essentially, as we go through this loop, right, we're, hey, what is our power? Our power equals this. We'll set that power. What is our power? Power equals this. Set that power, right? And so you're just going in that loop. So hopefully that makes sense anyway. So does anybody have questions on kind of this basic formatter structure? Or anything that we want to explore while we're all together? Anybody who has experience with doing the programming have any tips or tricks that everyone should know about?
Would you mind if I just showcased the Roadrunner SDK just so that people can see what's there and what's already built in?
No, absolutely. Yeah.
Okay, yeah. So yeah, I'll just share my, I'll get it all up and I'll share my screen.
Otherwise, here. I can demo getting it real quick.
Yeah, if you want to show where it's at, and then I'll get the SDK up on my computer.
All right, so here's the learnroadrunner.com. Get started. They have a lovely, quick start guide to help you out with everything, which is fantastic. But we'll go ahead and grab this here. And like Lee said, Roadrunner might be, if you are going to use Roadrunner, which I would recommend, you can build directly off of and straight out of their SDK, as it basically has the FTC Sdk built into it as well.
Yeah. Okay, I've got my version up, so I'll go ahead and just share my screen here. Okay. And this is something I will say that, I'll add this disclaimer that I am by no means a programming expert. This is just things that I've learned over the last few years on how to make these things work. But yeah, this is what the Roadrunner SDK looks like. And you'll notice it has a bunch of extra op modes. A lot of these op modes have to do with tuning it, the robot if you're going to do odometry. But if you want a good place on where to start and want something that's pretty well pre-built for you, you go to something that's called the localization test. What this localization test does is it has a pre-built program based off of two classes that you need to make sure that have all the right constants. The first one's called drive constants, which is this guy right here. Now, the nice thing about Learn Roadrunner is that it will actually generate a drive constants file for you if you want to. So you can go ahead, you can go over here, see where it says drive constants, it says configure me. And if you've got one of the commonly used chassis like the Strafer Kit V1 or the Strafer Kit V3 from GoBuilda, you can just choose that and it will automatically download all the correct information for you. Now, if you don't have that, you can just say, I'm using my own. It'll ask you what motors you're using. And it'll go through all the process and it will create a file for you that will match your robot. I'm not going to go through the entire process right now, but you can see it's very configurable. So you don't have to worry about having just to go build pretty much anything that's FTC legal. Or if by some thing you have a motor that's not on here, you can add all of the details in here and it'll do all that for you. So this is based off of the sample Mecanum drive, which this is great, particularly for students that want to do Mecanum, but perhaps doing the coding, particularly for students that haven't had trigonometry yet. Because if you're going to do Mecanum drives properly and program it on your own, you need to know trigonometry. I'd still recommend that this is a good thing to do once you've had trigonometry. I think this would be a good exercise for a team to, write a Mecanum program on their own, just so they can learn all the intricacies of it. But some people don't have the math to do that yet, so it's okay to start with this too, in my opinion. And then what you do is all of this is essentially compressed for you in this localization test, where the folks that run Roadrunner have already set it up for you, where it will do all of that automatically for you and has already set up the basics for you. So again, part of whether or not you should or should not use this is partially based off of where you are with your team. If your team is in a place where you want to learn how to do all the intricacies of building something like this, by all means. But also, you don't have to feel like you have to, quote unquote, reinvent the wheel with all of this. Because this program, as is, will drive a Mecanum drive, okay, while also giving you telemetry data down here on where your robot is based off of its estimates and things like that, depending on how you have the thing configured. So we're not going to get odometry is something we'd love to do next year with next year's thing. We definitely don't have time to go over that now, but just know that you can use these things within Roadrunner without having to do odometry. any questions on that? That's essentially all I've got here.
And Roadrunner has got a great tutorial quick start guide that goes through, explains all of the intricacies that it does for you, so that you know how to best leverage it and use it. So like, take advantage of Roadrunner, especially, for the camp. Take advantage of Roadrunner, experiment with Roadrunner, see if you like it better or not than what you guys have been using before, if you haven't been using it. If you have been using it before, maybe try leveraging some of its more advanced functions and features. The camp is ideally more of a means for you to explore and expand where you're at.
All right, well, I guess I'll stop sharing there.
So do we have any other questions or anything else we want to cover? That's all I had prepared for today. So kind of open questions / time for you guys to work together.
Okay, let's start my video up again. Okay, so why don't we talk about really quickly, so that's the end of the formal presentation. Let's talk about the 3 events that are tied to the sensors block and how, and let's just brainstorm some ideas together. So it's not just going to be us, telling you what to do or how to do it, but maybe we can brainstorm some things together here just as a group here. So the 3 events, the first one was the tape line events. So based off of now from what Laurel told me before she left on vacation, she had sent out the sensors and tape kits to each team, although they might not have gotten there yet. Has anybody received any of the sensors and tape kits yet? Okay, that's a no. Okay. If I recall, because I'm getting them too, I think they're scheduled to come earlier next week or early next week. So just so you know, each team is getting the same basic sensors and the same tape that will be used at the competition. That way, all teams are on equal footing as far as being able to practice with the same tape. Let me see if I can pull up the picture of the tape colors just so you can get a look here. So there it is. So all of you will be, and this is part of what went into the fees for this camp. You will be getting this set of 5 colors of tape. So you have yellow, orange, blue, green, and I would call that a magenta. I know that not all of us see the same colors the exact same way, but that's what I would call that. So for this event, your robot will be placed essentially on a line of tiles. Oh, got a thing in the chat, just want to make sure. Okay, is it 1 set per alliance or 1 set per team? It's 1 set per team. So each one of your teams should be getting this set of 5 rolls. So you don't have to get all together to practice. Each team will get that. Plus, it'll be great even if you're not the team that's doing this particular event. It's good practice. Good practice for other things. So from what I understood, it's each team should be getting each one of these. So the idea with this event is that you have a line of just a whole bunch of tape lines that your robot will run over. So you will want to, if you're using a color sensor, you're going to want that color sensor to point down toward the ground. So that your robot, or just make sure, if it's not like straight down. You just want it to be in a way where the robot can read what's on the ground. We'll put it that way. So let me double check something here, because if we hadn't done this before, I think we'll go ahead and do this now. Okay. Yeah. Let's set the tasks for what each color will need to be able to do. So there are 5 colors, and there will be 5 different tasks. I will type this in the chat once we've set all of these, just so that everybody has a copy of it. Plus, we'll add this to the formal rules here that we will sense every. We'll set it there. Okay. So, yellow. We'll have yellow. If a robot runs over a yellow line, the robot needs to pause for 5 seconds. So if the robot runs over a yellow line, the robot needs to stop moving. So it'll run over it and it'll pause for 5 seconds. Okay, everybody got that? I'll just write this in the chat too.
Yeah, I gotcha.
Okay, good, thanks. So we'll say yellow is a 5-second pause. The next color, let's do, so the next color is orange. Orange. Let's have the robot do a 360 turn. So just have the robot spin in place. So the robot just spins 360. And just so that we're consistent, let's say that it turns 360 turning clockwise. Okay. There you go. Third color. The third color is blue. Okay. Blue. Let's have blue where if you run over a blue line, you ignore whatever line comes after a blue line. And this is one of the more advanced things that we wanted to add to this, is how you can use one color to inform what happens next. So if you run over a blue, it means skip the next colored line that you run over.
Now, I want to mention one thing with the 360 turn is you have a very narrow space that this track is going to be on. So when you do your 360-degree turn, you need to make sure it is an accurate 360-degree turn, or you will drive off the track.
Yep.
So a 360-degree turn might sound pretty simple, but it needs to be a near perfect. Otherwise, your robot will drive off the track, and that'll get you a time penalty.
Okay. Green is the next color. And let's have green reverse direction. So if you're going forward, you hit a green line, you go backward. And if you're going backward, you're going to go forward. So green is reverse direction. Okay, and the final color, which is that magenta, that's what I'm going to call it. Okay. Yes, I'm glad you added that. Green does not mean turn around. It just means reverse your motor powders. That's a good clarification to have.
Hey, I figure we're in the programming course. We can use program not equal.
Yes, there you go. Okay. So magenta, let's say proceed to yellow, which means, correct me if I'm wrong on this. So magenta is proceed to yellow. That means ignore everything until it hits another yellow strip. So blue only ignores the next line, whereas magenta says ignore everything until you hit another yellow.
Are we doing black for the finish line?
Yes, we can, or white. Let's do white for the finish line. Okay, does anyone have any questions about the different? Okay, is the white line the one they're also following? That's for the maze event. So
yeah, so this is like a dash, so there is no so it's a time dash. So there is no line for your bot to follow. You'll need to rely on either your accelerometer or your gyroscope on your phone or some other sensor like that to help keep yourself pointed straight. But there's not going to be any guiding lines for your robot to follow. Yeah. So it's going to be two tiles wide. Your robot's placed in the middle, and then you have to go like 10 meters.
Yep. What is this event called again? Okay, the formal name that we gave to this was support station, is what I've got it listed as. Yep. So they're just squares of color on an unwise. So not squares; these will be lines. So
yeah. So the way that this will be set up, yes, this is autonomous. So the way that this is set up is that you have two of your tiles. So you have about a 3-foot space. Your robot's placed in the middle, and then it's 10 meters long. And across that 10-meter gap, there are going to be lines of tape across the floor, and it's a timed thing. So how fast can you go from start to finish?
Yep. While following all the instructions, because robots that do not follow the instructions based off of the lines will be assessed time penalties. Well, you know where the lines will be placed? No, you will not. Scary.
So with that, you could probably expect that you'll run into a yellow line to prove that you can do a 5-second pause, and that you'll run into an orange line to prove you can do a 360. But if you notice, we have blues and we have greens. So you'll probably run into a magenta and have it go over a blue or green or a orange, right? So you don't have to perform those actions if you're properly programmed. So you hit another yellow, and then you might have a blue before a yellow, and then you might have, right? So that's where this is going to be fun.
Yep. So
correct.
lines, yeah. Yep.
Yeah. So you'll start, you'll hit the go button, and your robot has to go until it hits a white line.
Yep. So we'll recommend that.
Yep.
Yep. So a single straight section crossed by colored lines ending with a white line, that is correct.
Of course, and I think the goal is to try and get detailed events out for this week. Is that correct?
Yes, that is correct.
So we'll get that out to you guys this week. If you do have questions, ask in the Discord. All of the event staff are there. I think me and Lave monitor it pretty regularly, as well as Kirby. And if we don't directly know the answer, we'll get to who does. So the Discord is going to be the source of the single source of truth. So yep. All of the rules that we talk about today will get put into a channel in the Discord as well.
Yes. Yep, so we will add that all to there. Okay, if there are no more questions, and again, if you think of any question later, like Macy said, just post it on the Discord. You can ping me if you want to, or you can ping, the staff, and we'll be happy to help you. Okay, the next event then is the autonomous maze. So that's event 5 is the maze. So there will be 2 possible ways to get through the maze. One is to use the line follower. So here is where the white line follower comes in. Now we've designed it on purpose so that the route the robot will take, which by the way, you will not know the layout of the maze beforehand. Again, we don't want this to be, because we think a lot of teams know how to use encoders to drive a specified route if they wanted to. And that's kind of not the purpose of what we're trying to do here. We're trying to help you folks learn how to use the other sensors and things that you have at your disposal. So there will be 2 ways for them through the maze. One will be a line follower. So we'll just have a line that will lead you through a safe, howbeit longer distance through the maze. If you've done, if any of you have done Lego League, which I know several of you have, the principle would be fairly similar to using a line follower in Lego League, if you'd like to do it that way. The other way that you can get through the maze, however, is there will be no line, and the robot will need to detect the walls that are around it. Now I did get a question in the Discord earlier today. Okay, so it's not just 2 methods, but 2 separate routes. That's correct. These will be 2 separate routes, and one will be shorter, one will be longer.
Correct. So essentially, the maze will exist. Calling it a maze is more technicality than anything else. The idea is that there will be a route from start to finish with obstacles in the way in the form of a maze. And the idea is that there will be a line that you can follow through the maze that will be the longest route possible, but you can follow that line and you will complete. So if you build the fastest robot possible for line following, you could technically complete this faster than anyone else because you're traveling a farther distance. There will be shortcuts that are built within the wall so that if you are able to detect where walls are, you can turn and take said shortcut.
Yes, that is correct. So I got a question earlier in the Discord about right-hand or doing a right-hand or left-hand maze. I've looked in a bit more into this, what that means. For those of you that are not aware, like I was before I got that question, is a right-hand or a left-hand maze is essentially anytime the robot detects that there's a branch, it either turns right in the case of a right-hand maze or turns left if it's a left-hand maze. I will tell you, it's probably not going to be that complicated of a maze. It's not going to be, if you're thinking about even the child's, big maze thing on the back of a cereal box, it's not going to be that complicated.
Yeah, I mean, we're talking something that's going to probably be at most 25 feet long.
Yeah. So
it'll be a very short course, but whether you design your robot to do left-handed or right-handed will not give you an advantage. It'll be purposely designed in a manner so that doing either direction will not give you an advantage.
Okay, Enoch asks, so if the robot crosses any part of the finish line, does time stop? Yeah, we'll just say that. We'll say the first part. Okay, yeah, just the first part of the robot crosses the finish line. It's done. Okay. Question: if the maze is that short, how are there shortcuts? Even shorter.
Exactly. So
even shorter than short. Okay.
Because you're going from point A to point B, and so it's less about the point the point of the event is for you to not follow the line through the maze, and to be able to be aware of your surroundings and be able to take and navigate your robot based off of sensors that are able to map the exterior. So the ideas behind this event is you can literally do this with something as simple as having 4 ultrasonic rangefinders, or as simple as 4 light sensors for being able to detect distance. Any sensor out there that can detect a distance, and having 4 of them on your robot, and have your robot be able to detect there's a wall to my either side, I can move forward. There's an opening to my left, I could turn left. There's an opening to my right, I could turn right.
Yeah.
It's designed to be very, very simple. Yes, if you hit walls, there will be time penalties.
Yep.
So again, it's a race to the finish. So that's why it doesn't need to be long, because it's not a can you complete it. It's a how fast do you go from point A to point B. And so essentially the idea is that you'll have a line that'll go through this obstacle, and there will be walls. Basically, you can think of it like a tower defense. You know what those are. You'll have a path through walls like this, and there may or may not be a shortcut through a wall at a certain point. And so you can take a shorter path is the idea if your robot is smart enough. Again, this is fully autonomous. So you put your robot and you hit the go button and it goes. And so either it finds the line and it follows the line, which will be the longest path, or it'll be intelligent enough to follow the line and possibly detach from the line and reattach or whatever else. Right. So, but the idea is go point A to point B as fast as you can.
Yep. Okay. Any other questions with the maze? Can you go over or through walls? Okay. Through walls is considered hitting a wall that will get you a penalty. Over walls, are you saying like driving over a wall, like climbing up and over? Is that what you're saying here? Spider-Man? Sure.
If you can go from point A to point B accurately without touching any walls,
yeah, I'll go with that.
That'll be my answer. If you can design a robot that will elevate itself above the walls without touching any of the walls and landing at the designated endpoint, sure.
Then go for it. How's
We're
that?
just going to build an AT-AT, because remember, it has to start within an 18-inch cube.
Yeah, just build it.
We still have that 18-inch sizing cube issue.
Right. So
yeah, I mean, if you want to just build an AT-AT that somehow starts in 18 inches, go for it.
Yep. It's one of the wonderful things about FIRST is that there are multiple ways to solve these problems. Okay, how tall can you make the robot? Again, your robot has to be able to fit within an 18 by 18 by 18 cube to begin with, but then it starts, it can expand to any size.
It has to fit within the building.
Yeah. Okay.
So I think we need to clarify. I think it needs to be when the last part of the robot crosses the line.
I'm
thinking of line, but when the full robot.
Yeah, if we're gonna allow that, yeah, you're right. You're right. Let's say, yeah.
I mean, that's typically how most of those work.
Oh, your poor idea.
The entire robot must cross the finish line.
Yeah, let's do that, because otherwise we're going to get some shenanigans. Well, we're going to get some shenanigans anyway, but we'll get more shenanigans than
what I love shenanigans.
Yep. So,
remember, like, the idea behind it, right? So
yeah. Just thinking about an expanding snake. Oh, yeah. That would have been fun. Oh, well. maybe some other time.
Hey, expanding snake, that would work. But yeah, you need to get and I think that's going to be for all the events, is the robot has to complete that task. So if it is elevated, the whole robot has to be elevated. If it's a robot going across the line, the whole robot has to go across the line.
Hey, any other questions about this event, the maze? Okay, can we have a finger type bit that touches? Yes, you can use a touch sensor if you want. I mean, that is one way you could approach this, just as long as you're not driving so fast that you ram into the wall and damage it. So yeah, you can use a touch sensor if you want to touch the walls, but yes, that would not count as hitting the wall.
Right.
So
the way that I would, if I were to write that out into a rule sentence, is I would say a sensor making contact with the wall for the purpose of determining location of wall will not count against you. However, if a robot is haphazardly touching the wall, or any part of the robot that is not a touch sensor is touching the wall, that would be an issue. Now, what I would say to that for clarification is, let's say you make a bumper. That bumper must only be supported by the touch sensors on your robot. Then it would be okay for a bumper to hit the wall. However, do not use excessive force, yada, 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 duck, right? It needs to be very clear that your robot is doing a sensoring operation, because this is going to fall down to the referee's discretion. So make it abundantly clear what your robot is doing. So move slow to touch something, not ram into it fast. I believe the walls are going to just be the standard FTC ring walls, right?
Yep, that's correct.
Yeah.
So if you've gone to any competition, we're making the walls out of the perimeter.
The perimeter walls.
Yeah, the perimeter walls. So, and best of 3 runs, yes, that is correct. You'll get 3 tries. And one of the reasons why we can do this is because there's only 2 robots, one for each alliance that's doing this event. So yeah, we'll give you 3 attempts each. So if you want to be sneaky, you could have 1 run that does the line follower just to make sure that you get a score, and 2 runs that try to do the faster way through the maze. That is a strategy you could do. Okay, any other questions? Or 1 slow run to learn the maze and 2 fast. Okay, I mean, if you can do that on autonomous, now, one thing you need to know is you can't code, so you can't be coding on the side during the event, so you can't have your computer out and type it. But if you're doing some sort of computer learning where the robot learns on its own, I can't do that, but if you could do that, go ahead. Just know that you can't code while you're at you can't code once the event is started, so you can't pull up your computer and change your code.
Yeah,
just know that.
Well, because of the nature of the event with the autonomous programs and everything else like that, you need to arrive at the event with your code, your like we talked about, right? Your production code needs to be programmed on your robot. We'll probably have a little bit of a grace period before the event officially starts in the morning. But at a certain point, we're going to say no more code can be written. So we're going to expect all laptops to be put away. We're going to expect Wi-Fi networks on the phones to be disabled, because the only thing that will be doing it is local triggers.
Yep.
Right. So we'll want to be able to trigger your robot probably with, walk over, you turn on your Wi-Fi, and either have a button on the robot that on the phone you hit to go, or if you have to use a controller, you can work with that as well. But the idea is you will not be able to do any programming or upload code or make any modifications on the day of the event.
Correct. Okay. Any other questions about the maze? These are great questions, and we're glad that you're asking these. It's better to figure these things out now than to try to figure them out on the day of the competition. Okay, so if the robot does fix a break, can you fix it? We're going to say to a degree.
Hardware, I would say, is fine. It's software that cannot be changed.
Right.
Software cannot be changed, but yes, hardware fixes and everything else like that is going to be fine. Again, you're going to have a time crunch just like you would with a regular FTC event. So it's not like, oh, my robot broke, I have 30 minutes to fix it. Nope, you're going to maybe have 5 or 10 minutes.
Yeah.
Right? If it's like, at most, you might be able to get 15 minutes to, do your physical hardware changes.
Yeah.
So like changing wheels, yeah, that should be fine. Make sure you can do it in less than 5 minutes.
So let me he's actually asking a little slightly different question. Will changes between events? So let's say you're doing event 1 and then you want to change wheels for event, say 4, the next time that you're running the event. You can do that. That is legal. You can also change parts of your robot if you want to, but you need to be able to do it. Let's say you need to be able to do it within 15 minutes. You need to be able to change everything on your robot within 15 minutes. And let's just say that.
Yeah. So across the board, you will not be guaranteed more than 15 minutes to be able to change.
Can the robot drop stuff?
As in leave a part of itself somewhere?
Like parts to make it lighter. During an event, no.
Your robot needs to start an event. Your robot has.
So not everything. Okay. So with the 18 by 18 by 18 rule, your robot at the beginning of any event needs to be able to fit within that 18 by 18 by 18 cube, whatever configuration it happens to be in. Does that answer your question? Okay, I'm seeing it. Okay.
So to answer Enoch's question, I would say, why does your robot have parts on it that it can easily just drop when you start an event?
Yeah.
I feel like the answer to your question is no. Your robot should have what it has with it when it starts, when it ends.
Yeah.
However, if you are making physical changes prior to your robot starting an event, yes, that is fine. But when you start an event, when you bring your robot over to start an event, that robot, the way it is at the start, all parts included with it need to end with it at the end of that event.
Yep. Okay, Enoch, oops, something fell off, just soldier through. Okay, so once, and this goes to something that Nick talked about earlier today, is if it's something that's incidental, if it's something like, oh, you ran into something and you lost a part, typically speaking, as long as there's not the intent there to break off pieces. If you're obviously ramming through that thing as fast as you can and with complete disregard for whether pieces break or not off or not, that's going to be a penalty. But we're going to give you the benefit of the doubt. Oh, okay. So he says, like, I'm thinking from Lego League when robots drop parts after doing the task. Okay. It's not going to be like that. No. No, we're not. It's not going. I think I know what you're talking about there. No.
You got to remember, each event is its own singular event. So if it's a time-based event, you're most likely not going to have something on your robot that can be easily detached to begin with. And if it's an ARM-based manipulation task you're probably going to need that arm the entire duration of that event. So I don't think there's any way that you would be able to benefit by having parts randomly drop off your robot.
Okay, last event then for this block, which is the Teleop Sensor. Okay, so with the Teleop Sensor event, we will be, so the referees will be hiding a picture from the Skystone. It'll be one of the navigation targets from the Skystone game. So we're using that one because it's the most recent part, SDK. A lot of your program things will have there. And we're going to hide it in a place where a team cannot see where it is. It'll be inside an enclosed box kind of area. And we're going to position teams purposely where they can't go and try to peek and see what the picture is. This will be in Teleop, so this will not be in autonomous. And what you will do is your drive team will drive the robot into the box, look and see what the picture is, and go to a specific point on the field based off of what the picture is. So the key thing is having your robot being able to see the picture and relay that information back to your drive team so your drive team knows what to do next.
Well, essentially the idea is you'll have like 4 or 5 stations. Each station is going to be this hidden box that your robot has to drive in, where only your robot is able to see what the marker is. You're then going to have that navigation marker that is going to translate to go to position 1 through 4, 1 through 5. I think it's 1 through 4. So you'll have a start one, and you'll go to positions. Once you've gone to all positions, you can then drive back to the finish. So your drive team will be responsible for to each position and getting your robot inside of the box. The box is going to be not much bigger than an 18-inch cube. So it might be like 20, maybe 22 inches big, and that's it. It's going to be a tight space. So you have to get your robot into there, and then your robot has to relay back to your drive team. You are welcome to use any means you would like to do this, whether that's an LED light on your robot, that's replying back to your driver's station's phone. However you would like to do that, I would probably recommend figuring out how to get it back to your driver's station phone. And then they will pull out of that box and go to whichever station it notates. And the stations will be marked on top with a piece of paper or some other identifier that says 1, 2, and you'll finish. And so it's essentially a time from when you start to when you get to the finish. So how fast can you get to that point? Understand which point is next. So next point could be 3, next point could be 2. And you're going to go over and hit all 3 points and then end in the finish.
Yep. Okay, so can you use a camera on the bot that would send an image back to the station? The answer is yes, you can.
Yep. Yeah, if you want to just send the image and you have your driver team has to figure out what that image means, great. I would recommend probably doing it far simpler so there's less stress. Hey, camera, what is this? That equals 1, right? There's lots of resources out there. And with us using Skystone, I bet you can literally go out there, find code from another team that has already programmed how to identify these, and then manipulate that code yourself so that it simply tells you if this is station 1, station 2, station 3. And we'll get that information out this week, what exactly each one means. And It will be randomized every single run. So you can't run a path.
Yep.
So that the image will always mean go to object 1, go to object 2, but where object 1 or 2 is located will be random.
Yep. And by the way, this is for the last event, for event 10, the one robot that's going to be do this part of random 10 is going to be doing more or less the same thing. But instead of having 4 boxes, you only have 1, and that one image will tell you which of 3 paths to take to get to the next part. So you will need to do this twice, essentially, as an alliance. So once the team that's doing it there, and then you'll need to do it a second time as the middle part of the 10th event, just so you're aware. Any other questions? And I'll open this up to not just these 3 events, but any of the 10. So are there any of the 10 events that people are still unclear about? Okay, what are the dimensions of the baton? You're talking about the baton for the 10th event. The baton is it is the top part of the wobble goal from Ultimate Goal. I can get the exact size of it, but yeah, that's what it is. The diameter of it is 1 inch, and it is 12.5 inches tall. So it's 12.5 by, and then 1 inch diameter. All right. Well, I think we're probably not going to come back after lunch. I think this is probably it for our Zoom meeting today.